Okay, in the last video, we focused on the UI. We added health bars, win and loss widgets, and a restart button to complete the core gameplay loop. In this video, we're taking combat to the next level by adding finishers. In this setup, a finisher is a cinematic attack sequence that gets triggered once and plays all the way to completion. Let's start by enabling the plugins. Go to Edit, then Plugins. Under the Animation category, enable these two plugins: Motion Warping Contextual Animation. The Contextual Animation plugin allows multiple characters to share synchronized animations, assign roles, and temporarily take control of the characters during gameplay. The Motion Warping plugin helps smoothly reposition characters so they line up correctly before the animation begins. After enabling both plugins, restart the project. Now head over to the content browser. Right-click, go to Animation Assets, and create a contextual anim scene. Name it whatever you like, then open it. You'll notice there's no role asset assigned yet. The role asset is used to identify which character is playing which role during the animation. To create one, right-click in the content browser and go to Miscellaneous, then Data Asset, then Contextual Anim Role Asset. Open it up and create two roles: Player, Enemy. Enable is character for both roles. Also, make sure the capsule radius and capsule height match the values used in your character blueprints. In my case, that's the AI character and the third-person character. Now go back to the contextual anim scene and assign the role asset you just created. Set the primary role to Player. This allows us to preview animations correctly once we add an animation set. If you want to customize the preview characters, you can do that under Override Preview Data, but this part is optional and won't affect gameplay. Next, click New Anim Set. A pop-up will appear. Under Data, assign your montage animations. For the player, I'm using a combo montage called Fury. For the enemy, I'm using Hit Fury, which is the reaction animation. For the movement mode, I initially tested both flying and walking. I found that in a side-scroller setup, flying mode tends to make the characters slide backward during warping, while walking mode slides them sideways, which actually looks more natural. The difference is subtle, so test both modes and choose whichever works best for your animations. If your characters are not properly routed to the capsule collision, open the animation asset used by the montage. Under Asset Details, enable Root Motion. Once you go back to the contextual anim scene and reset the scene, the animation should now align correctly with the character capsules. Now select the enemy animation track. Under Mesh to Scene, adjust the location and rotation values until the animations line up properly. For my setup, location Y is set to 120, rotation Z is set to 180. Now let's trigger the contextual animation through Blueprint logic. Open the player blueprint. I'm triggering the animation using the C key. First, get references to both characters. Use Get Actor of Class for the AI character. Use Self for the player character. Connect both references into Make Contextual Anim Scene Binding Context Nodes. Then connect those into Create Contextual Anim Scene Binding for two actors. Set the player as the primary actor and the AI character as the secondary. For the scene asset, select the contextual anim scene we created earlier. Then drag from Out Bindings and call Start Contextual Anim Scene. And that's it. Repeat the same setup inside the AI character blueprint. The only difference is that the AI character becomes the primary actor instead of the player. We won't trigger this with the C key, though we'll call it later through AI logic. At this point, if you play the game and press C, the animation should work correctly. But there's still one problem. The characters will snap into the animation regardless of how far apart they are. This is where motion warping comes in. Motion warping forces both characters into the correct positions expected by the contextual animation scene. To set it up, add a motion warping component to both characters. Then open both animations and add a motion warping window at the beginning of each animation. Set the warp target names like this. For the player animation, name it Player. For the enemy animation, name it Enemy. Now go back to the contextual anim scene. Find warp point definitions and add 2 elements, Player, Enemy. Set both modes to custom, then set the origin parameter to enemy. Whenever you make changes in this section, remember to click Update Warp Points. To reduce noticeable sliding during the warp, only allow the animation to trigger if the characters are within a certain distance of each other. In my case, I used a distance of 130 units. Next, we need to stop the AI from interrupting the finisher animation. Create a Boolean variable called ComboStarted. Before triggering another AI action, check this variable with a branch node. If ComboStarted is true, do nothing. If false, continue normally. Back in the player blueprint, we also need to check whether the contextual animation is still active. Drag from the contextual anim scene actor and call IsInActiveScene node. Once the animation is finished, set ComboStarted back to false. Now let's connect the hits from the animation to the enemy's health system. Open the montage animation and add Notifies at each impact frame. Right-click the animation track and create a new notify called ComboHit. Set the montage tick type to branching point. I found that the animation blueprint, in my case the Fight Anim blueprint, is the easiest place to receive anim notify events. Inside the event graph, add the event anim notify _ ComboHit. The plan is to pass this event into the character blueprints using a custom event called ComboHit. Whenever ComboHit is triggered, we apply damage to that character. For now, we're only triggering damage on the enemy AI character. Later, we'll make the system work both ways, so the AI can also use the same finisher against the player. You may notice that after the finisher animation ends, the enemy stays frozen in the knocked out pose. To fix this, add another notify at the end of the animation. Call it IsKnockedOut. We'll use this notify to trigger a get up animation afterward. Before continuing, this is also a good time to add Niagara effects to the Fury combo to make the attacks feel more impactful. Now let's fix the notification system so both characters can use the same finisher logic. The idea is to store the roles from the contextual animation scene and access that data from the animation blueprint. That way, we always know who is the player and who is the enemy during the animation. The role information is stored inside the contextual Anim scene bindings. So let's save that data somewhere accessible. Open the third-person game mode and create a variable called outBindings. Set its type to contextual Anim scene bindings and make it public. Now go back to both character blueprints. Right before calling Start Contextual Anim Scene, cast to the third-person game mode and save the outBindings variable. With that done, we can return to the animation blueprint. From the Anim Notify_ComboHit event, cast to the third-person game mode, get the outBindings variable. Drag from it and call getBindingByActor. From the return value, call getRoleFromBinding. Now use a branch node to check whether the role equals player. This lets us determine which character should receive damage during the finisher. Finally, let's add the get up animation after the knockout. We'll use the Anim Notify_IsKnockedOut event we created earlier. Use the same role checking logic from the ComboHit event. From there, use your locomotion Boolean variables to transition between knocked out, getting up. Add a small delay between transitions so the animations blend smoothly. If the delay is too short, the transition will snap. If it's too long, the character will appear frozen. Adjust the timing until it feels natural. To keep things organized, I also converted the transition logic into macros. And with that, we now have cinematic finishers, motion warping, synchronized contextual animations, hit detection, and recovery animations fully working inside our combat system.